Thanks for joining today to the introduction and technical overview of our GREENROCK saltwater batteries. I see in the participant list also very experienced persons, so this is an introduction to our saltwater batteries and some technical overview. So I just wanted to point that out in order that you get bored. Before we started, a couple of words about the webinar. On the right-hand side, you can see the chat functionality. When you feel something is not clear or you've got any other questions, please address that on the on that chat functionality. I will try to address those questions. Of course, if you've got some questions which I cannot answer on the spot, I will try to get the answers to you, and I also will provide a list of those asked questions to you in hindsight of that presentation. My name is Thomas Kraus. I'm Managing Director of BlueSky Energy. And before we kick it off, a couple of words about the company BlueSky Energy. The company was founded in 2012. We focus since then on electrical energy storage solutions. We have been trying and working with a couple of different storage technologies, and we got then stuck with that saltwater technology, as we call it. The technical term is a sodium-ion product. And now we are selling ready to install plug-and-play solutions. We call it GREENROCK. And those plug-and-play solutions are storage solutions which are including the inverters and energy management systems. We've got a GREENROCK Home product line starting from 5 kilowatt hours to 30 kilowatt hours. And we have also a GREENROCK Business line starting from 30 kilowatt hours to 270 kilowatt hours. And of course, we have got the cells or the storage units on its own, the stacks as we call it, which can also be deployed on specific projects. We strongly believe that a good battery takes years to test, because in reality, you can only tell how good a battery is after you made the practical experience with that battery. So we are very fond of that saltwater battery technology. Our longest system running in the field are now more than 6 years old, still very robust, still very good. And therefore, we are very happy that we found a product which is very robust and suitable for good practical applications. Of course, in that battery industry, there is a lot of variety, and we strongly believe that the battery should, of course, hold up to the marketing material, that is for sure. But on the other hand side, it should also work effectively in different temperature ranges, in different depths of charge situations, also in terms of C rates. That is a picture that you can make a little bit more out of it, how the whole thing looks like. A couple of participants, they saw the product already. So that is a 2.5 kilowatt hour stack, as we call it. And in total, we can see on the picture here, it's four stacks. So in total, those are 10 kilowatt hours. To start it off, and I want to make that clear, there is not the wonder storage technology or battery out there. And we do not have got the wonder battery either. We have got a product which is working fine in a certain range. And that range and the advantages of the technology is we are easily scalable, starting from 2.5 kilowatt hours to the megawatt hour region. We have got the capability, and that is to a certain degree unique, that we can fully discharge the battery without harming the battery, which makes it then in consequence maintenance free, because we do not need any BMS keeping a certain state of charge as we see it, for example, on lithium or lead product. The materials in there are non-toxic and all naturals. It's non-flammable, it's non-explosive. We work in a temperature range starting from -5 degrees centigrade up to 50 degrees Celsius. And therefore, as we have got a safe product, we have got no transport restrictions. As I pointed out, we have got not the wonder battery, we have also weaknesses. And one weakness is energy density. We are about twice the size than comparable lithium products. And the second weakness is that we have got a lower C rate. We are around 0.25 or ideally a little bit less. That's the comfort zone of that battery. So meaning when you need a lot of energy in a very quick time, we are the wrong guys. And that is something what we need to point out here. There is lithium much stronger on that front. We are a battery which needs about 4 hours charge and discharge time, and therefore we feel comfortable. And especially in the PV or solar area, we have got that time, so it makes us a good applications for PV or solar optimization with our batteries. So what's in that battery? Of course, we have got sodium. It's a sodium-ion battery, and that is our anode material. We have got manganese oxide as a cathode. Then we have got our salt water as electrolyte, which is sodium sulfate and water. Between the anode and the cathode is a synthetic paper, and that paper enables us that the ions can travel through between anode and cathode material, but it protects the anode and the cathode material that it's not getting interlinked. And then we've got a current collector, which is stainless steel, and then we've got a plastic housing. So all in all, we've got a very natural battery. One of my colleagues even drank the electrolyte, and he is still around. And from that angle, it's safe to say that we are the most environmental friendly battery on the market. So how does the whole thing work? A little bit more in depth how the whole thing works. So we are starting with the battery as we are loading electrical energy, as you see here on the right arrow, via the current collector into the battery. So the electric energy comes into the battery, and that triggers that the ions, then the sodium-ion ions, are traveling to the anode material, and they are getting then into the anode material. And that is then the charging process. Once all the ions are traveling to the anodes, then the battery is charged. And when we reverse it, then the ions are traveling back to the cathode, and the energy comes out of the battery. That is basically how the concept of that certain battery works. In general, we have got two versions of that battery. One is the 48 volt version, which is a nominal 2.7 kilowatt hours with 4 amps charge discharge. We've got the voltage range of 35 volts to 59 volts. We are charging with constant current. The depth of discharge is 100%. Round trip efficiency is above 85%. The maximum charge rate and discharge rate is 20 amps. And temperature, as already mentioned, it's at -5 degrees Celsius to 50 degrees Celsius. Life cycles, 5,000 cycles at 80% DOD. So that's the 48 volt version. And we have got also a 24 volt version, also the same charging. And that version, of course, can then make double amps because we've got the half of the voltage. In our battery world, there's always a lot of discussion in respect to cycles, and a lot of products are getting benchmarked on the cycles. So where do we stand on the cycle front? So we are at 3,500 cycles, assuming we would empty the battery 100% all the time, so making a 100% depth of discharge. And after those 3,500 cycles, we've got a remaining capacity of 70%. On the other hand side, when we are using 80% DoD, so not emptying it completely, our cycle life increases to 5,000 cycles, with a remaining capacity at 70% after those 5,000 cycles. When you would only half empty the battery, then we are at 10,000 cycles. And even if we would just only take 25% out of the battery all the time, we would be even at 20,000 cycles. So as you can see, the cycle discussion is always depending on a lot of factors. In this case, it's the factor depth of discharge. So when you are benchmarking battery technologies for your installations, for your projects, please take that into account to compare it apple by apple. And in a perfect world, when we have got 25 degrees centigrade, 5 amps charge discharge, we bring 22,030 kilowatt hours at 80% DoD out of that battery, which is a very good output of that battery. But of course, in reality, we won't see that lab situations all the time, because temperature varies, the depth of discharge varies, and the charging currents, of course, vary as well. In general, as with any battery technology, temperature is impacting the effects of a battery. And especially temperature impacts on storage capacity and on round trip efficiency. For our battery, we are rated at 25 degrees Celsius, and our storage capacity decreases if it's getting colder, and the storage capacity increases when it's getting warmer. So the optimal temperature range is around 50 degrees centigrade to 30 degrees centigrade, although, of course, we can also work in areas outside that, but that's the ideal area. And we have got the situation then, and that might sound a little bit funny on first sight, even if it's getting warmer, our storage capacity increases, and also the round trip efficiency increases. So therefore, the warmer it gets, the better it is. But we see at temperatures above 50 degrees centigrade, it's still an effective battery. It's still a safe battery, but there are then detrimental effects on the lifetime of the battery if we go beyond 50 degrees centigrade, and therefore we spec it up to 50 degrees centigrade. And from a comparison perspective, when we have got 0 degrees centigrade, we are at 65% of nominal capacity, and that should be taken into account depending on where you are deploying your projects. And that is with our technology, but it also needs to be considered when you're benchmarking to other technologies. They have got the same situations, so that need to be taken into account. Okay, we have got looked also, of course, into certain testing scenarios. For example, we did overcharge testing. We tried really to work very hard with that battery. So we overcharged it for 500 hours with 40% above nominal voltage, and no harm happened to that battery. So that was one test proving that is a safe battery. Even there would be a default on the inverter side, and the battery would be charged for 500 hours above nominal. Of course, we also did the short circuit testing according to UL 1973-14 standards, which we passed. No risk or hazardous topic came out of it. We did a gas evolution testing, which we also passed. Maybe also some background in terms of gassing. As with most battery technologies, when there is the intercalation of the ions, meaning that the battery is working, and it's charged and discharged. Of course, it's chemical processes going on here, and especially with electrolyte based on water, there is always a certain minimal degree of gassing that is not avoidable, but that gassing has been tested that is not proving any dangerous to anybody, and therefore we did that test to make sure that there is no harm coming out of it. And lastly, there is also an example of the imbalanced charging testing, meaning we tried to charge the different cells within a battery with different rates, meaning one cell was almost empty, the other one was overcharged. So there was an imbalanced situation with that battery. And also in that case, no harm and no problem occurred out of that scenario. And we passed that to the UL standards as well. So when we are using batteries, and overall photovoltaic or solar systems, there are, of course, inverters involved. One, we have got the PV inverter side, which can be used whatever you are using. So we are not concerned about the PV side. You are using your PV inverter as you wish to do. And then we try to connect with our battery systems onto your PV inverters. On the battery inverter side, we want to have battery inverters which are on 48 volt nominal, and the inverter's charge profile needs to be set, as I will show afterwards. In the most cases, it's like that you are using a LED battery charging, discharging profile and doing the settings accordingly. And there is a question, is there any compatibility with Studa? As long as Studa has got a 48 volt battery version, yes. And we did already projects with Studa. So from that end, I think Studa is one of those battery inverters which are a good fit for our batteries, and we executed projects with that already. So the charging is a constant current charging, and we are charging up to 59 volt charge, and then we cut it off and we change then into the float. And Studa is even mentioned here, hot by power. Those are just examples with inverters which we have been working with, but of course there are much more battery inverters out there. Our main criteria is really that the battery inverter is on a 48 volt level and can handle that. Over here, you can see the charging profile. So we are charging up to 59 volts when we have got the 48 volt nominal, or to 29.5 volt if it's a 24 volt nominal system, or to 14.7 volt if it's the small 20 volt system. So that's how we are charging it. We are charging it up, then we cut it off, we go into absorption and into the float. Basically, what happens then is once it's charged, then we're doing just with the float, and the absorption time is really to fill the battery up into a very gentle, safe mode to get the most out of this. Okay, I just got an information, cannot see this from Richard. Don't you see the slides? Don't you see the presentation? Okay, Thomas says, okay, slides are there, not always there. Okay, so some seem to see the presentation, some not, which I'm sorry for those who can't see the presentation. We, of course, will provide the presentation afterwards. but I'm not sure what I could do now, so I will just carry on and provide the presentation afterwards. Sorry for any inconvenience here. Yes, we will share the link of the recorded presentation. That will do, that you can watch it on YouTube if you want. Okay, then we have got the situation, and we had a couple of discussions on that front already. So how does the voltage translate into the state of charge? So when can we say how much volt is how much percentage of the battery? And that is drawn over here. So when we are below 40 volts, the battery is empty. And if we are above then the 55 volts, then the battery is full. And in the mean, that's the curve, what's shown here. So for example, the battery is 20% full if we are around 47 volts. And the battery is 40% full if we are at 50% volts. So that might help you in doing the settings. For example, if you want to do settings for your inverter where you want to keep a certain state of discharge, maybe for emergency backup reasons. So that would be basically the translation where you cut it off on the lower side. If, for example, you always want to hold 40% state of charge in the battery, then you would probably cut off at 50 volts, that you keep it in there. And there's a question, how much absolution time in the charge profile? Do you mean absorption time, Richard? That would be an hour. Okay, seems like. So I move on here. So besides the battery, we have got some technical possibilities which can help to optimize the performance of the battery. One is our GREENROCK combiner box. As you can see on the pictures over here, it's basically on the one hand side a DC distribution. So basically it interconnects all your batteries and consolidates your batteries and then brings a consolidated wiring out to your inverter. That is one functionality of that combiner box. And the second functionality is that we have got electrical shunts in there where we are measuring the performance of each stack. And therefore we can see and determine if the whole system overall is in balance. So it's a monitoring system on stack level, especially if we have got bigger installations where there are long or bigger systems involved. Then it's monitoring on the stack level that we see if all those stacks are in balance and get the same energy distribution. We've got also an alert functionality in there. If something is getting out of sync, for example, one stack is far less performant than the other stacks, then we are getting alert functionality that we can look into it proactively. We, of course, have also a temperature monitoring involved in there. That system can also be used in an off-grid situation because there is offline data caching. There's only topic what we need then to address is how do we get that data from that off-grid system, but the data is there and stored locally. And there is also the fuses are in there. So if there would be a problem with one of those batteries, then the fuses would protect our overall system. Yeah. And the BMS can be accessed via IP. We've got a certain API for that, and it works then with all the battery inverters, what we have been mentioning beforehand. So in all, the GREENROCK Combiner Box should make your life easier by installing quicker. There's all installation material involved, the cabling, the fuses, all what you need for your projects. Therefore, it should ease the installation on one hand side. And on the other hand side, it should make sure that the product is working properly and the overall system is in a nice sync. And as we all know, if we have got 10 batteries and one battery is not working properly, it drags down the rest. It's always a battery system is as strong as its weakest link, and therefore we need to have an eye on all those batteries if we want to have the whole thing working properly. Besides the BMS, we have got the EMS, the energy management system. That is basically now going a little bit more towards your customer. In the simplest form, it connects to your PV inverter. It visualizes the whole energy flow, how much energy is coming from the PV, how much energy is consumed in your local applications, how much energy is stored in a battery. So that's the simplest form what the EMS is doing. It's also a plug-and-play product, but it can do more. The beauty is that we can do also peak shaving or load shifting when we have got situations, for example, during the day, a lot of PV or solar energy is generated, but it's not consumed. We can do peak shaving or load shifting. DMS also enables us that we can do storage clustering. We can bring together a couple of GREENROCK systems to work together in a smart way. It makes then also the energy management and distribution and the online and offline battery control. So how can the EMS optimize the self-consumption? For example, we can integrate the EMS into a hot water heating element. So when we have got the excess energy from the PV, we can integrate to the hot water heating element, and then we can make hot water out of it, which can be stored in your boiler and be used then at night. We can also integrate with wireless sockets. So we can use flexible consumers, like in a household, the washing machine or dishwasher, in commercial applications that can be pumping or venting or stuff like that. Meaning, for example, that if there is excess PV energy, we can tell the washing machine to start in situations when there is excess PV energy and not in the morning when we are leaving the house. So those are opportunities to optimize your PV consumption directly. We can, of course, integrate into heat pumps. We can also integrate into e-charging or infrared heating. And of course, the whole system can be grid tied. We can also make AC coupling and DC coupling to the PV. We have also a hybrid inverter in our portfolio, which basically could then integrate the PV inverter and the battery inverter for new installations. That could be something which could be cost saving. Carrying on with the EMS, it's a web-based tool. We can do data analysis reporting. What we see is that the end customer is fond of that because the storage is in most cases sitting somewhere in the cellar or in the garage. But with that app, they can access their system and they can control or review it. They can see what is happening in their house, even if they are in the office. And it's very much liked by end customers to get a feel and touch and overview what that GREENROCK storage is doing for them. And especially also for off-grid applications, the EMS enables us that we can integrate multiple energy sources. We can integrate photovoltaic solar, we can integrate wind power, we can integrate water power, gas, diesel generators, and of course the grid. So we can move from a dumb battery to a real smart energy control system. And of course, can be accessed online, and we can interlink up to 3 different PV inverters with no additional metering. So it can be directly linked and communicates then with the PV inverter, which makes the installation much easier if compared to having the use to include meters all the time. There is a question, what is the self-discharge rate of the battery? And the self-discharge rate of the battery is around 1.5% per month. The self-discharge rate is depending on the temperature. The 1.5% we are seeing at 25 degrees Celsius. If it's getting colder, self-discharge is less. If it's getting hotter, the self-discharge of the battery is getting more. But the benchmark is we're talking about 1.5% self-discharge per month. So moving a little bit on from the normal stack-only applications, more a little bit to our complete systems. There is an example. All in all, we have got the concept of the GREENROCK home systems, which looks like having the batteries on the bottom, and on top we are using the battery inverter and the electronics, which includes then the battery management system, which I mentioned already, which includes the energy management system, which I managed. This is coming all in the pre-configured plug-and-play version, and it shouldn't take longer than 2 hours to connect that GREENROCK home system to your local grid. So that is something which should be an easy task once you have got to know the GREENROCK product. There's another question, what is the lifespan of the battery? And the lifespan of the battery is depending how you use the battery. If we are using an assumption for normal PV cycling, what we are seeing, for example, in Europe, and we have got the 5,000 cycles, we are talking about 15 years. That would be the expectation in respect to the lifespan of the battery, with having about 70% remaining capacity after that time. Of course, the lifespan will decrease. For example, if we are making the battery as a center and having, for example, 2 cycles a day, then of course the lifespan will go down. But in general, PV or solar applications, we are talking about 15 years, what is the expected lifespan of the product. Moving on from the home system, that is now our GREENROCK Business system. The business system starts at 30 kilowatt hours and goes up to 270 kilowatt hours. That picture shows a 60 kilowatt hour system. We have got on the left-hand side, there are the battery modules. Each of that pallet is holding 30 kilowatt hours, and you can staple up to 3 of them upwards. And next to it is then the electronics cabinet, again having the electronics in there, the battery inverter in there, having the EMS in there, and the BMS in there is all included. And those systems, the home system as well as the commercial industrial business systems, they can be grid tied, they can be emergency backup, so we've got the emergency backup or island mode off-grid functionality. We recently just did a project on a container. We can AC couple into the system. We can also DC couple into the system, but also, of course, do both of it. When we have got off-grid, then we strongly recommend that there is a certain part which is DC coupled, because when there is off-grid and we have got no energy left in the battery, we need some external source of energy to power up the system again, and that can be done with a DC coupling with a MPPT charger, which is DC connected to the photovoltaic or solar. And in a case where everything is empty and the sun comes up again, then the DC charger is providing that energy that the whole system is coming up into life again. If it would be only AC coupled, the battery inverter itself needs a certain minimum amount of energy that the whole thing keeps going. And then we would have a situation with an empty battery, that the battery inverter couldn't start again. PV is there, but cannot start again, and therefore we are bringing no new energy into the battery system. So when it's a purely off-grid functional is required, we strongly recommend doing DC coupled to a certain degree to enable us that we can provide the minimum energy once the battery would be empty. Okay, so we can of course be grid connected. That is how we do it in Europe all the time. Work off-grid. And as I said, the whole thing is all pre-wired, pre-configured. It's really easy to use. So I'm just trying to go through a couple of questions here. So on the home kits, 5 kilowatt hour, how many battery needed for 4,000 watt for 12 hours? So if we need 4,000 watt for 12 hours, then it will be around 50 kilowatt hours, I would say, that we can power that up. After 5,000 cycles, how much of the battery can be refurbished? Unfortunately, we cannot refurbish that battery. After 5,000 cycles, we've got a remaining capacity of 70%. And what is happening is that the whole electrolyte with anode and cathode material will get into a mesh. And there is currently no way to refurbish that battery. The only really valuable thing would be the stainless steel, which would be left, but there is no use to refurbish right now. Of course, our vision is that there is an opportunity that maybe it can be refilled at some point, but now we are not at a stage. So after 5,000 cycles, or when the product is end of life, it's end of life and it goes into the waste. So Nancy points out there is a battery calculator on the website. Yes, this is true. On our website, you can have a battery calculator, which gives you a rough idea how to dimension battery systems. But we will address the topic of battery dimensioning in more detail in one of our next webinars, because it's always a tricky topic. There's another question. Do you sell to Latin American countries? We love to sell to Latin American countries. The next question. How long does it take to ship to Nigeria? Our experience, we did a couple of projects to Ghana. Shipment is sea cargo because we have got some weight to carry. Normally we're talking about 4 weeks to Nigeria, I would say, without having the knowledge what the import procedure time is to get it into Nigeria. Curve of available cycles. Okay, can you share the curve of available cycles versus depths of discharged used? I can share the whole presentation where it's outlined. Do you recycle battery components? Unfortunately not. The only topic which is left is the stainless steel and the plastics. Would be wonderful to do so. I fully give you that. Now we have got no opportunity to do so, unfortunately. I will send out the presentations and also the contact details, and for discussions in respect to distributorship, which of course we are happy to enter those discussions, we can then use outline. I do not want to address that with each individually over here, but the normal procedure how we are working is that we are not selling to direct customers. We are always selling to partners, which ideally got to know our product. And what we are doing, especially internationally, we're trying to protect those partners because we understand and know that it takes effort to bring the word out and do the marketing for a new battery like we have. And therefore, we try to protect our partners to a certain degree, that they have got time to establish the business, to do the marketing for us, and hopefully then we establish a fruitful business relationship. Yes, when the battery is end of life, to clarify that, there is either the option you can send it back, depending where you are, but the most economical topic probably would be that you give it into your waste locally, because there's no harmful materials inside. You can basically put it into your normal waste or recycling procedure, which you have locally. But of course, there's also an option that you send it back to us. Cost of disposal, similar question here, is again very much dependent on the different countries, how much your normal waste really costs to dispose. But because it's not a special dangerous product, it's basically how much the waste is costing in your local country. Do you have already installed GREENROCK in the Middle East? Let me think. Unfortunately, not that I'm aware of. I would be happy to do so. How much weather protection is required? The protection it's an indoor application, apart from, of course, when we do a containerized solution, then the container is providing our shelter, but we do not want that the battery is standing in the sun, is out there in the rain. It's really an indoor application, but of course, with a container solution, we can put it basically everywhere we want it. Also, so I think I had the opportunity to discuss the major topics here. Just move it on. And there's another important topic, of course, is the topic of warranty. We are happy to give a 10-year warranty. We have got certain warranty conditions. Basically, what the warranty requires is that there is our BMS deployed in your installation, because that gives you as an installer or partner and us as a producer the opportunity to see what is happening with that product. And as long as the product is used according to specifications, we are happy to give those 10 years. But the BMS is protecting you as a partner and us, that we can obtain the relevant data, that we are ensuring the product is used according to specifications. Do we need batteries air conditioning and a negative effect on high temperature? In general, we do not need air conditioning, but it's really depending on how much temperature you're seeing. Certainly, we do not want to see temperatures beyond 50 degrees centigrade. If we can keep below 50 degrees centigrade, we would be needing no temperature air conditioning proactive. And for the island applications or the off-grid mode, do you sell it with inverters? Yes, we are selling it with a complete solution. There is the battery inverter included, there's the EMS included, it's plug and play, and it's a complete off-grid system. And yes, we are monitoring the battery conditions from our locations, basically a server concept what we are using, and that is what we use here. The major attributes what we are getting from the BMS and what is basically backing our warranty is the charge discharge rate and the temperature. That's the main ingredients what we are needing, that we see that the product is used according to the specification. Okay, let's move on to my next and last slide here. Today we had the introduction into technical overview. We will address the topic of installing the GREENROCK system and saltwater batteries on the 24th of October. So we go more into details, how to install it to your PV inverter and how the GREENROCK complete system is installed. On the 7th of November, we have got a separate session which is talking about dimensioning. How much should that battery be in relation to your PV, into your grid, into your off-grid, whatever. And then we have got another session coming up on the 21st of November talking about GREENROCK energy management system. And in general, that is probably something which is coming also from a dimensioning topic. When we have got a battery of 5 kilowatt hours, we say as a rule of thumb, the PV should match the capacity on kilowatt peak. But of course, that is also depending on your region. So in general, when we have got 5 kilowatt hours in storage capacity, we should have 5 kilowatt peak as a photovoltaic to power the battery up. Of course, in countries with more sun, that is something which can be less, but we would need to look at probably on a regional basis. Can we buy additional warranty? In general, we give the 10-year warranty. That is our standard, and we do not go beyond that. That is basically where we stand right now. So just to see, there are a couple of examples of projects what we executed. There's a school in Ghana, there is a farm in Austria, there is a school in Sweden, there is a company in Germany, there is a garage in Belgium. So we have been selling worldwide happily, and are of course happy if we could bring you as interested that we can engage and start projects with you. To clarify that, when the battery reaches 70% of remaining capacity, there are still 70% left as a capacity in the battery, and it can still be used. The only topic is that the battery is at 70% capacity, and for us then it's a sign that the battery capacity is going too low, but it still can be used. It's not getting dangerous, whatever, but it will deteriorate over time and the capacity will go down. But it's no problem from that sense. In general, when we've got the remaining capacity, it's not about the voltage drop. It's basically you do not bring more energy into that battery. That's the main topic, really. When we have got a 10 kilowatt hour system and we are reaching 10% remaining capacity, then there you bring only 7 kilowatt hours into your battery, and that is the main topic here. And the cells, they cannot be stacked on top of each other. There was another question, can the cells be stacked for the home size systems for shipping use? No, it cannot be used. We do have a concept right there. It's always on the floor, the installation and the shipment. Okie dokie, there are no further questions. I say thank you very much for taking the time and engaging with me today. I will provide you with the link of the YouTube video and the presentation. Again, sorry for those who couldn't see properly. And I also will address questions afterwards happily. when you got my contact details. How do you get in touch? We will send out the contact details of myself and the presentations, and based on that, I would be happy if you reach out to me and address questions which I couldn't cover today, or engage further for looking into a hopefully fruitful business relationship. Okie dokie. Thanks again. All the best. Ciao from Austria. Talk to you soon. Bye-bye.